Hey guys, time to go over section 3, aka unit 8 of what we learned in Algebra 1. Let's do this thing, okay? First thing that I think is going to be, that we need to review, or be helpful to review, is what polynomials are called, and we name them by two different categories. First, you name them by degree, and second, you name them by the number of terms. Hopefully the handwriting is a little better on today's lesson. Okay. If something is degree 0, we call it constant. Okay. If something is degree 1, it's linear. If something is degree 2, it's quadratic. If something is degree 3, then it's cubic. If something is degree 4, it's quartic, and so on and so forth. And 5 plus, you just say degree 5. Okay, if something is one term, then we call it a monomial. If something is two terms, we call that a two wheels is a bicycle, so binomial. And most of you guys have got this down. 3 is tri, and 4 or more is, we just say poly, which means many, polynomial, right? Okay, cool. So let's see a couple quick examples. So how about negative 3x to the third? Let's just do that. What's that? That is one term, right? It's multiple things in a product, but it's one term, so that is the degree is the exponent here. It is a cubic monomial, one term. Okay, now if I were to add plus 4x squared, this is degree 3, this is degree 2, this term, okay? Degree 2 term, degree 3 term, you just take the sum of the exponents of the variables, just the variables, so degree 3, degree 2. This one is more, so the whole polynomial is still cubic, except now we have more than one term, so it would be a cubic binomial. And lastly, if I added something like plus 1, it would turn into a cubic trinomial. If I added something like plus x to the fourth, well now I've added, it's not in standard form, the 4 would have to be in the beginning, but now I've added a third term. It's still a trinomial, but it's no longer cubic because the highest degree is this highest exponent here, 4. So now it would be a quartic trinomial. And that's how it works. The most one you're going to see the most often probably on the final is quadratic or linear, and it's just going to tell you to use those, words. Okay, next section. So you're just naming in the first section. Section 2 is adding and subtracting. I'm going to just do some quick examples here. Basically, all this is combining like terms with a little bit of sugar on top. Okay, 3x plus 5 plus x squared minus 10x. Okay, what you're doing here when you're adding, you don't have to worry about changing signs or anything. It's just combining like terms. I've got 4 terms: 3x, 5x squared, and 10x, and it's not in standard form. This is degree 1. This is degree 5. This is degree 2. This is degree 1. Okay, so the highest one we said was 2, so we're going to start with that, and there was only one of them, so I can just say this is equal to x squared. The second highest was 1, as there was 2 of them, 3x to the first and negative 10x to the first, so we add their coefficients to get negative 7x to the first, and then there was only one constant, plus 5. So there it is, adding polynomials. Okay, let's do a subtraction one. Okay, if we had done, let's do a little bit harder one maybe, x squared plus 3x minus negative 4x squared plus x plus 7. Okay. When you're subtracting polynomials, it's the same thing as combining like terms, but it's not ready to combine. The other one was ready to combine. Here, you have to change the sign of everything and in the next. And if this is old news for you, feel free to skip it in the video. That's why I have it on here. This is a study guide for you. So you're changing the sign of everything in the second group when you subtract. So this negative 4x squared becomes positive 4x squared. this positive x becomes negative x, and this positive 7 becomes negative 7. And now that we've taken care of distributing that minus 1, we can add things together. I've got 4x squared and 1x squared. This is degree 2, degree 1, degree 2, degree 1, degree 0. 1, coefficient of 1 plus 4 gives me 5x squared. 3x minus x gives me plus 2x. And we just have one constant, minus 7. Cool. Next one. Okay, multiplying polynomials. The most important one for you to have down are multiplying things like x minus 3 times x plus 6. Let's do one of these, something easy. Okay, multiplying, the method I taught you was the car method, shown up to a party. Everybody from this car has to meet everybody from the other car. And by meeting, I really mean multiplying. So you're kind of doing this FOIL, it's called FOIL, or the distributive property, multiple times. X times x is x squared. X times 6 is plus 6x. Negative 3 times x is minus 3x. Negative 3 times 6 is minus 18. Okay, we have multiplied correctly. We have not added like terms. You'll end up with x squared plus 3x minus 18 in its final multiplied form. If you've got something with more like 3 terms or 1 term, you need to, you're going to be adding those exponents together. Let's do one that's maybe a little bit harder. Let's do one with just distributing 1 really fast, like 7x squared y times y cubed minus 2x to the 5th. Okay. Here I'm distributing a monomial into a binomial. And when we multiply these things, you just are adding the exponents associated. So 7x squared y, there's already a y, I'm going to be adding 3y, so that's going to be 7x squared y to the 4th. Okay. 3 plus 1 is 4. And then over here we're not going to be adding any y's. You do 7 times negative 2 is negative 14. X squared times x to the 5th is x to the 7th. And there are no y's, so that one just comes along for the ride. Okay. And if you have one with 3, let's say like x squared plus 2x minus 1 times x minus 5. Okay, if you're multiplying something with 3 in one and 2 in the other, you have to make sure you do every introduction. So in this case, you're going to be multiplying 2 here, 2 here, okay, and 2 from negative 1. 2 multiplications there. So total of 6 before you add and combine like terms, so please be careful there. Also watch out for ones like so. Okay, if you are doing something squared, the common mistake is to write this as x squared plus 1, and that is just flat out wrong. Okay, don't do that if that's your inkling. You need to multiply it out long ways, x minus 1 times x minus 1, and do the same process you did up there. That's x squared minus x, right? X times x plus 1, which ends up being x squared minus 2x plus 1. Factoring. I think you guys are fairly good at this. Use your factoring flowchart, which means you start at the top, always start with the GCF. The 8 and the 24 share an 8, so 8 is part of our GCF. X squared and x share an x. Okay, and then whatever is left over. Remember the technique that I gave you? You could do like 8 times x minus 8 times 3 times x. What do they share? They share an 8. They share an x. What's left over? X minus 3. Great. Factored. Okay. Notice how there's no zero product property here. We don't have an equation. We're just writing this as a product. I need factors of negative 24 that add to 10. If you're thinking 6 and 4, you are incorrect. I love this question because there's more than one option here. Okay, the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 6 and 4. Hope I didn't miss anything. Okay, and notice this, there's multiple different ones that have a difference of 10. Since this is actually negative 24, factors of negative 24 that add to 10, they have to subtract 10, not add to 10. So you really want 12 and 2. And this has an a value of 1, which means we can use guess and check, which means I can go straight to my answer like so. This will be x minus, which one's got to be negative if they add a negative 10? Well, the bigger one, so 12. So x minus 12 and x plus 2. You can check. X times x is x squared. X times 2 is 2x. Negative 12 times x is negative 12x. And negative 12 plus 2 is 10. Okay. Negative 12 times 2 is negative 24. There it is in factored form. These two things are equal. Now, there's a difference between factoring and solving. And so if I say solve this, and I need an equals 0, okay, solve this, that means find the x values that make it true. And one method for solving was factoring, so I don't want you to get those two things confused. Factoring is part of the solving process. In order to solve this, we'd need factors of 3 times negative 4, which is factors of negative 12 that add to 11. Okay, those are going to be 1 and 12, and the 12 will have to be negative. So we're going to write this as 3x squared minus 12x plus x, 1x, right, minus 4. We are using the break apart method. The reason I'm using the break apart factoring method is because a is not equal to 1, it's equal to 3. Okay? Found factors of negative 12 that add to negative 11, and there they are. Negative 12 plus 1x, because the x is tacked on. Pull out the GCF of the first two. That's 3x times x minus 4. And right here is plus, well, it already is x minus 4, so that means that the GCF is 1. Sweet. Okay, great. We're still not quite done factoring. Now we have to pull out this common factor of x minus 4. So you have x minus 4 times 3x plus 1 equals 0. Okay, great. We have not solved. We have successfully factored, but we've not solved because we have not said which values of x make the first equation true. That was our job. And we do, however, have the ability to solve now that we're factored. It's easy once you're at this spot. You use the zero product property. It says if you have a product equal to 0, you set each factor of that product equal to 0 and solve. So if x minus 4 equals 0, then the whole equation equals 0. So that means x would have to be equal to 4 by adding 4 to both sides. Okay, 3x plus 1 equals 0. Subtract 1, subtract 1. 3x equals negative 1, so x is equal to negative 1 over 3. That's the zero product property. Our two solutions are x equals 4 and x equals negative 1/3. Contrasting that to what we did here, I didn't ask you to solve, so be careful of that. They might be throwing stuff at you on the final. Make sure you know whether you're just factoring, which is just writing it as a product, or solving, which adds the zero product property step. So if there's an equation you're solving, it's just an expression you're factoring. Hey, thanks for watching. Things are going great down here. I hope the YouTube videos are helpful. Okay, we'll see you soon.